Could a sliver of crystal, clearer than glass and almost as hard as a diamond, be protecting your most prized technology right now? It is more than just possible. It is probable. Consider this powerful fact. A sapphire crystal is so resilient that it can be scratched by very few materials on Earth, making it a nearly perfect shield for the delicate electronics we rely on every single day. This incredible strength is not magic. It is pure science. It is the result of atoms locked together in a perfect, unyielding formation. This essay will pull back the curtain on this amazing material. We will explore what sapphire is, how it is made, and why its presence in our lives makes our world safer, clearer, and more durable. So let's embark on a 12-minute journey to unlock the real benefits of this extraordinary crystal. At its very core, sapphire is a specific mineral called corundum. Think of corundum as the basic building block, a crystal, made from two elements, aluminum and oxygen, forming aluminum oxide. In its purest form, corundum is completely clear, like ice. But nature rarely keeps things pure. Tiny trace elements mix in as the crystal grows, like a drop of paint in water. Iron and titanium make the crystal turn blue, sapphire. Chromium makes it turn red, ruby. In science and industry, sapphire often means pure, clear corundum. Its defining trait is hardness, not color. Scientists use the Mohs scale to measure scratch resistance. The scale runs from 1, talc, to 10, diamond. Sapphire scores a 9. Only diamond or sapphire can mark it. A key reason it is valuable beyond jewelry. It resists everyday wear, dust, sand, keys in your pocket, accidental scrapes. That resilience keeps sapphire surfaces smooth and clear far longer than glass or plastic. The incredible hardness of sapphire is not a magical property. It comes from how its atoms are arranged. If you just stack bricks loosely, the wall is weak. Arrange them in an interlocking pattern and bind them strongly. You get a formidable wall. Sapphire's atoms are tightly packed in a repeating trigonal crystal lattice with almost no empty space. Powerful aluminum-oxygen bonds act like a dense network of super strong, short springs. To scratch or break sapphire, you must push atoms apart or sever those bonds, which takes enormous energy. That's why sapphire resists scratches from most other materials. The atomic fortress grants heat resistance. Sapphire melts at over 2,000 degrees Celsius, about 3,700 degrees Celsius. That's more than 3 times aluminum's melting point and higher than steel. So sapphire is useful in high-temperature environments where glass would deform. It's chemically inert. Strong acids that attack metals or plastics leave sapphire unharmed. Hardness, heat resistance, and chemical stability make sapphire ideal for reactor windows and medical gear. Sapphires can be born in 2 worlds, deep within the earth and in highly controlled laboratories. Natural sapphires are geological masterpieces formed over millions of years under immense heat and pressure. Trace elements like iron and titanium tint the crystal, creating blues, pinks, yellows. Brought near the surface by volcanic activity and found in riverbeds or rock deposits. Each natural sapphire bears tiny inclusions, its geological signature. Synthetic sapphires are grown in weeks using purified aluminum oxide, chemically and physically identical to natural sapphire. Same structure, same hardness, same clarity. Labs deliver precision, predictable sizes, purities, and forms for optics and electronics. They can form large sheets, solid rods, and thin wafers tailored to industry. Lab production is more cost-effective and typically has a smaller environmental footprint than mining. Natural gem sapphires stay rare and precious, while lab-grown sapphire quietly powers scanners, sensors, watches, and phones. One common method is the Verneuil process, flame fusion. Finely powdered aluminum oxide melts in an oxyhydrogen flame, forming droplets. Droplets land, cool, solidify, and crystallize on a rotating pedestal building up a single, large crystal, a boule for watch glasses and bearings. The Czochralski method melts pure alumina in a crucible, often iridium, and dips a seed crystal. The seed is slowly pulled and rotated. Molten material solidifies onto it as a single crystal. In Hem, a seed sits at the bottom of a crucible. Everything melts except the seed. Precisely lowering the temperature grows a massive, low-stress sapphire block upward from the seed. The result? High-quality sapphire for windows, lenses, and other precision components. Rough crystals are cut with diamond saws or lasers into discs or tiny cover windows. They're polished through progressively finer diamond slurries to remove microscopic imperfections. This final finish delivers sapphire's signature clarity and tactile perfection. Sapphire's most famous superpower is its extreme hardness, 9 on the Mohs scale. Common glass is 5.5, hardened steel, 6.5. Sand, quartz, 7, easily scratches glass, not sapphire. A sapphire watch crystal can look new after years, while mineral glass shows micro scratches. High-quality sapphire is transparent from ultraviolet through visible into deep infrared. It's ideal for scientific instruments and optical systems. Your phone's sapphire lens cover lets in maximum light for clear, sharp photos. With a melting point above 2000 degrees C, sapphire maintains strength where others fail. In high-powered lasers, sapphire handles heat without cracking or deforming. It resists chemicals and is biocompatible for implants. Electrically insulating, sapphire substrates prevent stray currents in LEDs and microchips. Strength, clarity, and stability. Together, they make sapphire uniquely versatile. And it does all this while remaining optically pristine. One of the most recognizable uses, watches. High-end makers use sapphire for the protective crystal. On wrist, it shrugs off bumps, scrapes, and abrasive surfaces, staying clear for life. It may add to upfront cost but minimizes future polishing or replacement. The small lens on your phone is vulnerable to tables, pockets with keys, and drops. Scratches cause blur and flare. A tiny sapphire cover prevents that and keeps photos sharp. Supermarket scanners use sapphire windows to resist countless slides and scuffs. In labs and reactors, sapphire viewports endure vacuum and heat, enabling observation. In medicine, sapphire blades and endoscope tips withstand repeated sterilization. High-powered lasers rely on sapphire rods and lenses that won't degrade under intense light. From jewelry counters to clean rooms, sapphire bridges beauty and performance. It's the quiet material behind smooth checkouts, clear photos, durable watches, and reliable instruments. The most immediate benefit, long-lasting durability, a mark of quality and longevity. For daily essentials, sapphire translates into peace of mind. Minor mishaps don't become permanent cosmetic damage. Unlike plastics and some glasses, sapphire resists haze, yellowing, and UV degradation. You get a perpetually clear view, whether reading a dial or capturing a memory. In industry, sapphire's strength means safer viewports under stress. A tougher phone lens cover is less likely to crack, protecting delicate camera modules. Though pricier upfront, sapphire often saves money and hassle over years of use. It's the classic case of buy it nice or buy it twice. Side by side, sapphire and high-quality glass can look identical, but performance differs. Sapphire is Mohs 9, window glass about 5.5, Gorilla Glass 6.567. Chemically strengthened glass resists keys and coins, but not sand or quartz. Sapphire can only be scratched by diamond. Glass softens or cracks under extreme heat. Sapphire survives above 2000 degrees C. Hence, glass is unsuitable for furnace and many laser optics, but sapphire excels. Sapphire transmits from UV to IR and can be polished to ultra-smooth surfaces. That means less light scatter and fewer distortions for high-resolution imaging and lasers. Glass is abundant, moldable at lower temperatures, and cheap to mass produce. Sapphire is complex and energy-intensive to make. therefore more expensive. It's reserved for applications that justify the cost, premium durability and performance. Glass remains the versatile, affordable choice where extreme durability isn't required. Sapphire is far more than a pretty gemstone. It's a titan of material science. Its near-perfect atomic structure gives it hardness second only to diamond. It resists the scratches and scrapes that deface lesser materials. Earth-grown or lab-forged, sapphire remains tough, clear, and stable. It serves on our wrists, protects our cameras, and shields harsh industrial processes. Unmatched durability, a perpetually clear view, enhanced safety, and long-term value. From precious gem to high-performance component, a story of human ingenuity. Next time you check the time, take a photo, or pass a scanner, remember sapphire's unseen power. In a disposable world, sapphire stands for lasting quality. As technology advances, its role will only grow. Sapphire. Beauty harnessed into everyday benefit.